Good morning. It's Monday, October 5th, and we are going to go over today's lesson, which is section 211. So chapter 2 is about variables and how to simplify and write algebraic expressions. We're going to be comparing more complicated algebraic expressions and figuring out how to solve for the variable if we know that two expressions are equal. Now, don't freak out if you don't know what I'm talking about, because that's what we're going to be learning about. So today's lesson, specifically, you are going to learn what the algebra tiles are. And algebra tiles give us a very concrete way of learning about a very abstract topic. So we're going to use the little shapes to help us figure out how to combine like terms. So the first thing we have to do is name each of those tiles. So we are going to start off by going to the tiles. So these are the algebra tiles, okay? There are 6 different tiles, and you'll notice that they have some similarities between them, but they also have very significant differences. So for instance, this is the base tile, basically. It's a 1. We consider it 1 wide and 1 tall. And each block is named based on its area. So this is 1 times 1 is 1. That's why we call it a 1 square unit tile. Now, if you take that 1 tile and you measure it with this light blue tile called an X, or with the Y tile, they have the same width as a 1. If we try to measure an X tile, you will see that it doesn't quite line up perfectly. And they design the tiles like that because they don't want it to have an exact value. So if we do that with our Y tile, oh, well, that didn't work right. There we go. They design it so that they don't line up perfectly. I just goofed that up a little bit. So this length of the Y tile and the length of the X tile end up being unknown values, and that's what a variable represents, is something that we're not sure of its value. If you notice, the squared tiles have that same X length on both sides, and X times X gives us X squared. Y times Y gives us a Y squared. Y length gives us Y squared. And then this last tile is called an XY because it's Y wide and X tall, so it's an XY. So what we can do is we will take a bunch of tiles and just pull them out here randomly. And what happens is we can simplify this by going, okay, well, I have a 1 and an X and a Y and a Y and a 1 and an X, a 1, and X squared. But that just is like saying if you're going to the grocery store, you need a banana, and an apple. It'd be much easier to say I need to pick up 3 bananas and 2 apples. So we do the same thing with our tiles. We put all the tiles that are what we refer to as like terms, or the same kind of tile, together. And by doing that, what we can do is then name them. So if I want to name this whole collection of tiles, I just write down what I have. I have 2 X's plus 2 Y's plus 4 1's plus an X squared. Someone else might have put them in a different order. They might have started with the x squared first and written x squared plus 2x plus 4, or 2y plus 4. As long as you have all four pieces individually, what we call terms, each of those four pieces are being added together. It doesn't matter what order they're in. So we are going to try a problem. They ask you to build the collection using the tiles. So 3 x's, 5, x squared, a y, 3x squareds, and a 2. So I'm going to go to my tiles and pull out those values. So I need 3 x's, 5 1s, 1x squared, 1y, 3x squareds, and 2 1s. So this is how it was presented to us originally. Well, I want to rearrange it so that it's easier to write out all of that. So if this is what I started with, 3x, 5, x squared, y, 3x squareds, and 2, I can rearrange it by putting all the 1's together, the x squareds together, and the y's together. And now, by doing that, I can write that statement more simply by saying I have 3x plus 1y plus 3x squareds plus 7 1s, 1, 2, 3, 4, 5, 6, 7. The one thing you need to be careful of is if you're going to type this in on a computer and you try to type the x squared piece of it, it's going to show up as, if you were writing the whole thing, 3x plus y plus 3x. And when you try to put in the 2, it's just going to come up as a normal 2 plus 7. We need to know how to make this an exponent right here. That's pretty significant. This actually makes it look like 3 times 2 or 3 times x times 2, and that's not correct. So there are a couple of ways we can do this. The easiest way that we're going to use right now is to use what's called a caret symbol. And this symbol is right above the number 6 on your keypad or on your keyboard. You'll see the number 6, and above it, you see this little point of an arrow. And what that tells us is whatever number we type next is supposed to be an exponent. Homework tonight was section 219 or 211, numbers 7, 8, and 9. If you have questions, make sure you sign in to the 2 o'clock office hours with Mr. Copland or me. Have a good day.